So the topic of theory of mind or mind reading started with Premack and Woodruff's 1978 paper. It was refined by Dennett in 89. And the big paper, the seminal paper that gave us empirical research on theory of mind, specifically in relation to autism spectrum disorder, was a 1985 paper by Baron-Cohen, Leslie, and Ute Frith.
That's right. That's the one that Bermudez focuses on.
I had a conversation with Dan Dennett once where he said, yeah, it really shouldn't be called theory of mind. When you think about monkeys up in trees and they're swinging from branch to branch, they're brachiating, right? They're brachiating when they swing from branch to branch, that's what it's called. But they don't have a theory of brachiation. They're just doing it. It's the same with people and mind reading or theory of mind competencies. The cognitively typical individual does not have a theory of mind. It's only really the people who are lacking, who have a deficiency in that respect, who have to do any kind of theorizing. It's just intuitive.
That's right.
So that's where the mind reading, that's why we have two words for it, is because we came up with a term for it and then people said that's a stupid term for it.
Yep.
I think the competencies Bermudez talked about in this chapter are good examples of modularity in that they seem to come apart both in ontogeny, developmentally, so you acquire one, and acquiring one doesn't seem to have bearing on the acquisition of another, maybe sequentially, but you get one and not the other. And also in disorders, for example, in autism spectrum disorder or attention deficit disorder or psychopathy, psychopaths are perfectly good at mind reading and just don't have empathy. And people with autism spectrum disorder, ASD, or people with attention deficit disorder, ADD or ADHD, they're perfectly good at empathizing. They're very good at empathizing. But the tracking of other people's mental states while they're interacting doesn't happen easily there.
Right. That's why I think it's a good example for modularity, for just to connect them to last week.
Behaviorally, it's a good example of modularity, but it's not as though we know that there's some part of the brain that is responsible for X or Y or Z.
That's right. It's just that they come on. Somehow, there's something that changes. That's that you didn't have. The same thing is true, right, with apps. You don't know, when you add an app to your phone, you don't know where it went. It's just in there somewhere.
So we have the equivalent of software modularity in that these things come apart behaviorally, psychologically, but in terms of the underlying neuronal hardware, we don't know if these are modular at all. And in fact, I'd be willing to bet that they're not.
I would too, but we don't know one way or another.
One of my favorite lines from the cognitive scientist Doug Hofstadter that Daniel Dennett likes to quote is, "Anything you can do, I can do meta."
Yeah.
As a statement about what's special about the human mind, actually, about what's special about human cognition, in that
whatever you can do, I can do meta maybe about 5 times. After that, you lose track.
One background piece was decoupling and meta-representation. Maybe we could recap what meta-representation and decoupling are.
Sure. All right, so here's a start. Many of the students asked about what meta-representation meant. I was puzzled by that, so I looked to see where he actually uses the terms. He says pretend play, this is about pretend play now early on, rests on a basic portfolio of meta-representational abilities. These meta-representational abilities permit primary representations to be decoupled from their usual functions. That is, you're ignoring the fact, it's just a matter of ignoring the fact that the representations, when you look at the coffee cup, you're really thinking about the coffee cup, right? When I think about you believing that you have a coffee cup from Tufts, that's decoupled from, it's not as if I'm particularly even thinking about the coffee cup.
Right.
For one, you could be wrong, right? Or I could be.
Yeah.
Maybe there isn't really a coffee cup there. You just have a nice little picture of one that you hold up periodically and pretend.
Or I could.
And the idea that seems to be moving is that on the one side, you can have representation. Say, Mel may believe that she has a coffee cup on her table. Mel believes that she has a coffee cup from Tufts on her table. Her belief is a representation of the coffee cup. My belief that she has that belief is a meta-representation of her representation.
So when I'm going about my life, moving objects around, I might be drinking coffee from this cup. I might be about to eat this banana. These are first order representations. First order representations are the kind of basic representations that we use when we're engaging with objects out in the world in our everyday activities. A meta-representation allows some degree of counterfactualness to enter. Our representations can become counterfactual, so I can represent this banana as a telephone.
Hi, how are you?
Or I can represent this coffee cup as being full of wine and not coffee, or as being empty and not full.
That's right. So a meta-representation is just a representation that includes some representation in it. So Mel believes that she has a coffee cup from Tufts is a meta-representation. I'm not thinking about the coffee cup. I'm thinking about Mel.
You have a mental state, a representation of another person's mental state, my mental state.
A representation of a mental state, hence meta. By the way, meta came about historically is kind of fun. It started with metaphysics in the library at Alexandria in ancient times. The library had scrolls and they would put them in slots, sort of like mail slots. And there was a slot for physics and the slot above it was for metaphysics. That's why metaphysics got called metaphysics. It was in the slot above the physics slot.
So it's above. Meta is above.
Above physics.
Very good.
Layered on top of.
And it works. Etymologically, it works. I have a representation of a banana, and you have, or I have a representation layered on top of that decouples the banana from its real world instance and brings it into something more abstract.
Right, exactly.
So it is kind of a representation layered on top of a representation.
That's right. So that's the idea of meta-representation and decoupling. They do go together in a way, right? Because when I say Mel believes that she has a coffee cup from Tufts, I'm, in a sense, really decoupled from worrying about the coffee cup. I'm interested in what Mel believes.
You're not committing yourself to that belief that the coffee cup is from Tufts or that I have the coffee cup.
Absolutely not.
Some of our students had drawn connections to philosophy of language, things like the use-mention distinction. This maps right onto the use-mention distinction. So I have this banana, and I'm talking about the banana. I'm using the word banana, and then I can mention the word banana and say it's got B's and A's and N's in it, repeated, or it's got this many letters. And similarly, when we talk about meta-representation, when we talk about having beliefs about other people's belief states, this maps right onto the whole conversation about quantification. My belief is only quantifying over the individual who has the belief and isn't quantifying over the belief. So I'm not committing myself to believing in that belief that I believe some other person has.
That's right. It's almost the use-mention distinction, but not quite. Bermudez at one point suggests that you can treat the content of the belief, the stuff that comes after the that clause, as if it were a sentence mentioned.
Right. Right.
That's not quite right. You can't really, because if you're just mentioning the sentence, if you quote the sentence, say you translate it, you don't translate what comes between the quotes, right? So if we point out that Mel believes that she has a banana, we translate that into German, we're going to translate the word banana too, right? If we say Mel accepts the sentence, Mel said that I have a banana.
Doesn't quite work because the word banana is the same in German. Sorry.
I didn't even realize. I didn't know what the word for banana was. Okay, Mel believes she has an apple. That's close, but it's not the same word. But if I say Mel says I have an apple, then I don't translate the words I have an apple when I translate that into German. We say Mel glaubt I have an apple. That doesn't work. But the use mention is like that in the sense that it has at least indirect reference, not direct reference. That's the way philosophers often talked about it. That would be Frege more than the use-mentioned distinction, I suppose.
True.
But it does not commit me to thinking you have an apple or a banana, or that you're even there.
Should we talk about pretense, about pretend play, and why that factors in?
Sure, now we're backing up to the story of the chapter, really. The chapter is a story about the addition of mental capacities. That's why it's a developmental and psychological story. What happens as children grow, right? What comes on first? The first thing that comes on is the ability to pretend and to play, which they can do without having any of the rest of the capacities.
Right. So first we're just dealing with concrete real-world objects. My flatmate was very nice to lend me this banana for the sake of the lesson. But we're dealing with concrete real-world objects. We have a spoon, and once we're able to grab the spoon,
We're able to use the spoon to shovel things into our mouths. And we're able to use the rattle and shake it to make a sound, because we like the sound. And we're able to throw the rattle on the floor so Mom can pick it up. And then we move on to something that abstracts away from the real-world objects and their actual real-world properties, their actual real-world functions, and pretend that the banana is a phone, or pretend that there's food in the bowl and I'm using the spoon to scoop the food into my mouth, even though it's empty. I'm able to pretend that there's food there because I'm able to have a conception of the bowl and the spoon and their functions that abstracts away from their actual properties in the moment. I have a conception of them as for eating. And I can play eat, or I can play telephone, or I can play drink from the cup.
Yeah, the child will take the spoon into the bowl and they'll say blueberry yogurt, yum. And the kid will go, yum, right? They're pretending it tastes good.
Or I can turn the bowl upside down and take my spoon and bang on it like a drum.
Or you can make it into a hat.
Or it becomes a hat, right? There are all sorts of things that it could become, and the fact that we can take objects and lend them with properties, mentally lend them with properties that they don't actually have, is what we're talking about here. And that's going to scale up to pretend play that's involving of other individuals.
Right, so far it can all be done just with one person,
Right.
Just one kid with their bowl and their spoon. Doesn't have to involve any other people.
But then you might take your bowl and your spoon and say, do you want some soup? Or, hey, pick up the phone. And then suddenly it becomes a game involving others.
Right, and that's sort of the next stage.
And that already involves a kind of precursor of full-blown theory of mind, because in some sense it involves your toddler having the sense that if they can pretend that the banana is a phone, you can pretend that banana is a phone too, and you can go pick up the banana over there and talk to me with it. Or if I can pretend that I'm making a soup with my little cereal bowl and spoon, then you can pretend that you want to taste my soup.
That's right. And that's something that comes on later in development, say at maybe age 4.
Really?
Yep.
Not till 4?
I think 4 is about at least what Bermudez says is the age.
For full-blown other involving pretend play. Interesting.
Yeah. In Leslie's model, the ability to engage in mind reading emerges in normal children between 2 and 3 years after the ability to engage in pretend play. If pretend play emerges at age 2 or 1.5, then you're looking at 3.5 to 4 for the emergence of mind reading in this sense of mind reading, this lower sense, so that you can pretend to play with others. But that's why it emerges later. It's added on in subsequent development.
So I think we understand that there are 2 kind of milestones of mind reading. One of them is at 2.5 years. They start to be capable of a kind of basic mind reading. And then full-blown mind reading comes in at maybe 4 years.
Right.
There are 2 things I wanted to say about that. One was that there was mention of mind reading coming in much earlier. That's a study by Onishi and Baillargeon that looked at 15-month-old infants. Infant comes from the French enfant, which means without language. So by definition, we're talking about babies before they have learned to use words. Infants just sit and drool.
And they look at things.
And they look at things, importantly, yes. So when you want to go and study the mental capacities, the cognitive capacities of children in development, when you want to study how we acquire capacities throughout development, and you want to start with really little ones, with infants, they can't answer questions for you. You can't ask them something and they'll tell you the answer when they're infants, because they're by definition without language. At a certain point, you can get them to pick up the cup that you think Sally thinks has the marble under it. A pre-reaching infant can't even do that kind of thing. They can't reach out and grasp something because they just don't have the motor skills yet. So then we still have a method of studying them, and that is called looking time experiments. There's a looking time paradigm, and there are two looking time paradigms, importantly. One is affiliative. And there, the idea is that the infant is going to look longer at something that they like or that they want, and less long at something that they're not interested in. The other looking time paradigm is a violation of expectations looking time paradigm. And there, the idea is that the infant is going to look longer at the thing that surprises them, at the thing that they didn't expect. So we know the basics of the Sally-Ann task, right? I have Sally and I have Anne, and Sally and Anne are playing with their dolly together, and then Sally leaves the room. It's just Anne, and Anne and I are gonna hide the dolly under the bed. Then Sally comes back in. Where is Sally gonna look for the doll? Up until they have a theory of mind or mind reading capacity, babies, toddlers, are going to think that Sally is going to look under the bed where Anne and I hid the doll, because they can't differentiate between their own first order belief states and the meta representation of belief states that Sally must have, right? Sally doesn't know where the doll is because Sally was gone. The idea is that we can do this. The Onishi and Baillargeon study says that we can do this with infants and then have Sally come back in and go look for the doll, either in the place where the doll was when Sally was in the room, or in the place that we now know the doll is after we've taken it and hidden it somewhere. The idea is that if Sally goes and looks for the doll in the place that we've hidden it, the infants are going to look longer because it violates their expectations that Sally is going to look for the doll in the place that she last saw the doll, right? Yep. I don't believe in looking time experiments in infants. I have methodological issues with these. For one, because we are free to interpret their gaze in two completely different ways. One as in, I like that, and one as in, that surprises me. Apparently this Onishi and Baillargeon experiment has been replicated, so whatever.
Yeah, but that doesn't relieve them of your worry.
No, it doesn't.
The same thing over and over again. That just means they can interpret it over and over again as well.
Yes.
I have no doubt that children will behave in a regular way, but that doesn't mean we know what's going on in their minds.
Oh, I have worries that a lot of psychological science, that a lot of cognitive science is just p-hacking. We're just fishing for statistical regularity somewhere.
What p-hacking means for the students is you're just searching for statistical significance.
Yeah, we're searching for some task that we can do, some experiment that we can perform where we get p equals less than 0.05 or p equals less than 0.01 regularly. And then we feel free to interpret that as meaning something significant about the human mind or the human brain, right? But really it's just we don't know what it is. And the worry is that we do all kinds of experiments and we get statistical chaos with 8 of them, and then we hit on one where infants consistently look longer at A versus B, and we say, oh, that's a finding, right? And then we publish those results, but we're not publishing all of the null results, all of the results that weren't statistically significant. So it paints a picture as though we're honing in on deep truths about the human psychological ability when it's groping in the dark.
There may be problems. I agree that there are problems like that with looking experiments, with looking paradigms. They're variously interpretable.
Right. And that's a problem with a lot of a lot of cognitive science, but especially a lot of cognitive science with babies, because the babies can't tell you what's going on in their minds.
It's also a problem with adults, since adults usually deceive themselves about what's going on in their minds.
That too, yeah. But at least they don't, take their feet and shove them into their mouths halfway through the experiment and just like drool everywhere. Anyway. That happened to me once. I was trying to code looking time and the thing just takes its foot and
Much more interested in the toe.
Yeah. And then there are people who are doing stuff on theory of mind or mind reading in non-human animals. For example, in chimpanzees, like the whole Tomasello crew, etc. They were at the Max Planck Gesellschaft, EFA, Evolutionary Anthropology, and they were doing great work with in Leipzig. They're doing great work with non-human animals, with primates. And then, Hare and some other people came out of that and were doing work with dogs. There's great work, for example, Banyar, I can't pronounce his name. He's doing great work with corvids, so corvids are crows and ravens, and they're very, very smart, very, very smart birds, and they've been doing some theory of mind work with them. Cecilia Hayes has pointed out that there are confounding factors, that some of these experiments could be resting on what we call in comparative cognition a clever Hans effect. This is a fun one. Clever Hans was a horse who could do advanced mathematics. How could he do it? We would give him a mathematics problem, and he would stomp his feet the number of times of the answer, right?
Yep.
Now, it turned out that what Clever Hans was doing that was so clever was he was looking at his trainer, and at the point that he should have stopped, at the point that he reached the correct answer, the trainer would inadvertently, not to his knowledge, have some kind of facial reaction or some kind of gestural reaction, and then Hans would stop, and he'd give the correct answer every time, right? Because the trainer was giving it away to him. So the worry in experiments like this is that you have confounds or a clever Hans effect where it's actually that there's some experimental variable that the organisms, the non-human animals in your experiment are tracking that is not the thing we think they're tracking. So it's not that they're actually representing the mental states of other birds or dogs or chimpanzees.
The horse was not adding anything up.
No. He was tracking some other extraneous variable. And the idea is that we're always worried with these kinds of, especially comparative cognition, that there's some kind of extraneous variable that the organisms are tracking. Mm-hmm. So Cecilia Hayes has been a real push for methodological rigor and for really honing in on what would need to happen experimentally for us to be able to actually conclude with some degree of certainty that a certain organism in a certain experimental protocol is actually resting on a theory of mind or mind reading. And she's resting on a great 2013 paper by Butterfill and Apperly that talks about minimal theory of mind competence and a more maximal or full-blown theory of mind competence, and has all of these important desiderata for that. That's great. That is great work in theory of mind.
There were many questions about IQ, as if IQ means intelligence.
Right. So one, I don't think intelligence is all that real of a psychological construct. I don't think that's a robust, culture-independent psychological construct.
It's also many things, not one.
Right.
There are different kinds of intelligence. IQ was historically done to assess the ability of children to perform as students. That's what it was doing in the original work by Binet in France. It was just meant to identify students whose work could be improved, who were underachieving. For whatever reason, it didn't say anything about it being innate or being genetic. It just said, this is where they're performing. So it's often very much verbal tests. It got distorted later and treated as a measure of general intelligence, but that's a bad inference.
Like the GRE, like the SAT, the Stanford Binet, and later the IQ test that came out of that, they're all aptitude tests.
That's right.
They're aptitude tests, and that their statistical function is to predict success.
In school.
Right. And so what they're doing is they're predicting how likely you are to succeed. And later we've come to interpret that as telling us something about your innate faculties. That's where the issue lies, is that leap from it's just a predictor of how well you're going to do at some task to...
That's right. And they're often just very conventional and arbitrary tasks.
And it started out where they'd give you a picture of the original Binet tests at the end of the 19th century. They give you a little picture of like a flapper girl and an ugly witch and asked you to tell which one was uglier. Like that was the kind of question they'd give you, is which of these is uglier. And even though we've gotten away from those kinds of absurd, biased questions that were on the original Binet tests, each successive revision of the tests up into today's IQ tests have had to be statistically equivalent to the original tests. So even though they're not asking stupid, culturally biased questions anymore outright, they're having to ask questions that do the same statistical work as those original problematic questions. So basically I wouldn't say it's been debunked, but scientists no longer think of that as corresponding to anything real in the world.
At least many scientists. There are people who still believe that they correspond to real things in the world, and they mostly live in testing centers.
They're paid quite a lot to go on believing that IQ is real.
And it's interesting to track it, right? There's a set of Princeton tests. Those are the SAT and ACT sorts of tests. And then there are the Berkeley tests, which are one-factor IQ tests. So whether you believe in that there are two types of intelligence, quantitative and qualitative, or one type, IQ, depends on whether you're on the West Coast or the East Coast. And they all are selling tests to schools. That's where they make their money. And they do believe it. And they do believe and defend the idea that IQ or intelligence is innate.
And then in the 80s, Howard Gardner came along and said there's not one kind of intelligence or two kinds of intelligence, but multiple intelligences. That's the work on multiple intelligences.
And that number, the number of kinds of intelligences has only expanded over time.
Yes. Or you could be the real radical and say intelligence is fake.
Isn't it different than thinking there are 18 kinds of intelligence? I mean, if the students want something to read that's approachable and fun and interesting, I think it's Stephen Gould's The
Mismeasure of Man.
Yeah.
That book is approachable, it's smart, it's on target.
It's an excellent book. It's really an excellent book.
And it's skeptical.
Yeah.
So one question was...
Has the development of that theory of mind been used to predict intelligence or IQ?
Yeah, so does your performance on theory of mind or mind reading tasks as a child predict future IQ as an adult?
It would probably be no.
Yeah, so the first answer is IQ is fake. IQ is not real. It's not a valid construct. The second answer is pretend that IQ is real. IQ and mind reading, IQ and theory of mind capacities, completely statistically decoupled. Doesn't seem to be any relationship between them.
So very smart people may have no sense of mind reading abilities, that in the sense that they're using it. They may be very extreme on the autism spectrum disorder.
Right, so you get autistic savants who have basically no capacity to do mind reading at all.
That's right.
And who are just off the charts in terms of IQ, especially in terms of single factors of IQ. There are certain kinds of tasks that they just excel at in a way that neurotypical individuals can't do at all.
One example of this is the famous case of Temple Grandin, who is at the Colorado State University, I believe, works with cattle often and livestock. She doesn't really, and she'll admit, she doesn't really have a sense of what other people are wanting or thinking, but she can figure out the way the livestock are responding in ways that are just absolutely stunning.
And she's an excellent biologist, right?
She's a biologist. She focuses on domestic breeds of cattle, sheep, horses, and her brilliance comes in recognizing what makes them nervous, makes them comfortable, what spooks them, how to design things in their environment so that they're maximally comfortable. And yet, she doesn't read people at all. She doesn't make eye contact with people. You can spend a whole dinner conversation at a table with people and she'll never make eye contact with one person at the table. She'll talk about her work. She'll never ask about their work. If someone walks into her office at Colorado State, she won't offer them, she doesn't naturally just offer them a place to sit, even though there are chairs there. She has on her desk a list of things that she's supposed to do, and she uses that. She's learned to sort of cope with social interactions that way. So one of the things on that list is ask people to take a seat. Another is offer them a cup of coffee. Another is ask them why they're here.
I should have a list like that.
And she uses it as a way of getting through life and not insulting people.
I just insult people.
It doesn't come naturally. And so she's on the autistic spectrum, but she's a brilliant biologist and brilliant about lots of things. I didn't say what her IQ was. I don't know.
I think it might help to illustrate what we mean with ASD, so someone on the autism spectrum, someone with autism spectrum disorder. If we're reading a book, we are able to think along with the author of that book, what the author of that book is thinking. If we're having a heart-to-heart conversation, I am able to feel with you what you are feeling. I can empathize with another person's emotional state, but it's like stepping into another operating system. So you know how your computer is either a Mac or a PC or a Linux or what have you, and you can be in the Linux mode and then partition the hard drive of that computer so you can step into a Mac build or you can step into a Windows build, right? Or you can have your little Mac that's operating on Mac OS X, right? And then you can have a virtual machine that's running Windows. Normal people in everyday interactions and everyday conversations are in one operating system, and they've got all these little virtual machines open that are tracking what other people think and feel. People on the autism spectrum don't have that. People on the autism spectrum, they're in their operating system, and if they want to be in what you think or feel, they've got to fully step out of what they think and feel and into what you think and feel, and that's very disruptive and not useful in day-to-day interaction, so they only do that very rarely.
It's very hard for them.
Right, and you can't...
The ones that are extreme on the spectrum.
Yeah, and you can't switch tracks. You can't be having a conversation with three people and monitoring what those three separate people are thinking and feeling. You just gotta roll with whatever you're thinking and feeling, because trying to predict what they're thinking and feeling is just impossible. And because it's basically impossible, because it's so difficult, you know, it's really for normal people, for neurotypical people, it's intuitive. They just intuitively know what other people think and feel. For someone on the autism spectrum, it's a work of deep theorizing. They have to think very, very, very hard and bring all of their knowledge about human beings to bear on the task of figuring out what someone's thinking or feeling, right? So doing that in day-to-day interaction, that would take all of their cognitive ability to do that. So they don't.
Right. It's as if the way Bermudez tells the story and Leslie tells the story, it's as if someone who can engage in, say, pretend play, but can't figure out what other people are thinking, just never quite adds in that extra app that other people add in. The app that says track other people, tracking eye direction.
But people with ASD don't typically do pretend play at all.
No, that's right. They don't.
That's one of the first diagnostic criteria for
Earliest
ASD.
diagnostic criteria.
First red flag is can't suspend their disbelief and pretend that the banana is a telephone.
So there's something that other people can do, they just can't. Or it's very difficult. They can sometimes, like Temple Grandin, they'll find workarounds, but what they won't do is do it the way the very socially adept individual does it. They'll find a different way to monitor when people are uncomfortable or angry or whatever, but it'll be much more mechanical. They'll look for a frown, where the rest of us often don't have to look at a frown to see that someone's angry.